How does arriving precipitation become stream flow? This particular question is related to the study of stream runoff generation mechanisms, or how it is that the water that we see flowing in streams and rivers got there. Where did it come from on the hill slope? And in general, there's a whole bunch of different pathways that hydrologists have studied, and we're going to overview some of the most important ones. The simplest pathway, I'll maybe call it the zeroth, or the number 0, is that, of course, you can get direct precipitation on the channel itself, on the stream channel. So this is fairly obvious, I hope, but if you have some stream and it's raining and it falls directly on the channel, that's going to contribute to stream flow. Okay, building up from this, we will talk about 2 different kinds of overland flow mechanisms. And one of these you've already seen before, and it's called infiltration excess overland flow. And because it was first described so thoroughly by Horton, it's commonly known as Hortonian overland flow. So you'll see this in the literature and hear people talking about Hortonian overland flow. The idea here is that if you were to draw a 2-dimensional vertical hill slope cross-section, precipitation is arriving, but it can't infiltrate fast enough. And so it starts flowing over the ground surface down to the stream channel where it becomes stream flow. And so this type of overland flow occurs when the rainfall intensity exceeds the infiltration capacity. And we can think of this as saturation from above. And I'm going to say this in juxtaposition to the next runoff generation mechanism that we'll study, which is saturation from below. So this is a kind of quick shorthand for how to think about it. Some hallmarks of this particular type of overland flow: it's real fast. It's very rapid. So the response in the stream to a rain event is going to be very fast, second only probably to direct precipitation on the channel. It's common in places where you've got lots of impervious cover. So for example, in an urban environment where there's concrete covering the ground or buildings. It's common in semi-arid environments. It's common in places where the infiltration capacity has been reduced due to anthropogenic activity like compaction, or temporarily due to things like the freezing of the ground surface so that water can't infiltrate, or perhaps after a fire when you have hydrophobic soils. So these are some of the places where we expect to find this particular type of overland flow. And again, we'll contrast this with the other runoff generation mechanisms that we'll talk about next.